Hi student, let us see NCERT chapter number 1 example 1.9. The question here is 2-point charges Q1 and Q2 of magnitude plus 10 to the power minus 8 coulomb and minus 10 to the power minus 8 coulomb. One is positive, one is negative, respectively are placed 0.1 meter apart. Calculate the electric field at the point A, B and C as shown in figure 1.14. So figure 1.14 is this one. See student, to solve any problem of physics we need to keep some important things in our mind. First thing is to understand the diagram properly. If you understand the diagram properly, 80% of your work is over. Next is your formula. If you know the formula, then you can apply the formula in the diagram. So first of all, let us understand the 80% of the problem, that is the diagram. Okay, here we are having a triangle. The name of the triangle is not required. As seen from the question, it is understood. In the diagram only it is given. Each side is of 0.1 meter. Okay, so it is equilateral triangle. All angles will be 60 degrees. These are basic mathematical facts you should use and apply in all the physics problems. Okay, I do not think that I should repeat it again and again. Next, we have to find the electric point at point A. This is one point A, then B and C. Okay, and where are the two charges? Plus charge is situated at Q1, that means Q1 is plus charge and Q2 is the negative charge, that is minus. Okay, and what is the point C? C is the point where we have to find the electric field. A is the point where we have to find the electric field. Again B is a point where we have to find the electric field. Now we'll see the distances. Point A is situated at a distance of 0.05 meter from Q1, same distance from Q2. Now we'll go to point B. Point B is situated at a distance of 0.05 from Q1 and from here to here, see the distance. Okay, this is 0.05 plus 0.05 plus 0.05, total is 0.15. Point B is situated at a distance of 0.15 from the charge Q2. Over. Let us see the third point, that is point C. Point C is situated at a distance of 0.1 meter from Q1. Point C is situated at a distance of 0.1 meter from Q2. Now we have completely understood the diagram. Okay, next we will go for the formula. Which formula to be used here? We have to calculate the electric field. So what is the formula for electric field? Electric field E equal to K Q by R square. K is a constant, Q is the charge. Okay, from the charge we have to see, here we are having two charges, and what is R? R is the distance between the charge and the point where you want to find the electric field. Next, let us see the three different points and the direction of electric field at these three different points. This is very important. So we'll go to the point C. Let us see the point C. Okay, so point C, at point C we will give the direction of electric field due to charge Q1 as well as charge Q2. Now see, Q1 is positive charge, so we know that the direction of electric field in a positive charge is radially outwards. So the direction of electric field will radially outwards like this, in this direction. So E electric field of charge Q1 at C, it is E1C. Again Q2 is negative charge, so electric field will be radially inwards like this. So the direction of electric field is in this direction towards Q2, and the name of the electric field is E due to 2 at the point C, E2C. What will be the resultant of this 2 vector? Okay, this is important. we should learn how to find the resultant of vectors. So we are having two vectors, one in this direction, one in this direction. So the resultant will be in between them. How to find EC? EC will be equal to root over of E1C square plus E2C square plus 2 into E1C into E2C, then cos of the angle between them. This is 60 degree, this will be 120 degree. Okay. Next, let us move to the point A. Okay, this is point A. At point A, see the direction of electric field. At point A, Q1 radially outwards like this. So it is E electric field due to 1 on A, E1A. Next, negative charge towards this side, this side. Are you seeing the arrow mark? So it is E electric field of 2 on A. So at point A, here I have shown one is E1A, E1A towards right. Second one is E2A again towards right. Okay. Next, go to the third point, that is point B. Point B. See the point B. So at point B, this is a positive charge radially outwards like this. So electric field of 1 at B, E1B is towards left side. Let's see the negative due to Q2. Q2 again towards itself. That means in this direction, just the opposite direction. It is electric field of 2 at point B, E2B. So we'll replicate here. At B, 1 is towards left for positive charge, radial outwards left, and for the second charge it is towards right. Okay. After understanding this, now we will go for finding the magnitude of electric field. So first we will find the electric field at point A. We know the formula. So you see here, already I have mentioned what is the direction of the vectors. If two vectors are in the same direction, then they will be added. If they are in the different direction, they will be subtracted. So at point A, you see both are in the same direction, so they will be added. So here I have taken the magnitude of EA equal to magnitude of E at point A is equal to magnitude of E1A plus magnitude of E2A. What is the magnitude of E1A? E1A. Okay, E1A due to this Q1, it is equal to Q. What is Q here? Q1. Okay, so K into Q1. What is the distance between Q1 and point A? It is 0.05 square plus E2 due to second charge. So K into Q2. What is again the distance between A and Q2? So here you have to see this distance from Q1 to A, then Q2 to A. Both the distances are same, that is 0.05. So here we have seen that charge Q1 and Q2 are of the same magnitude, that is magnitude of plus 10 to the power minus 8 equal to 10 to the power minus 8, magnitude of minus 10 to the power minus 8 equal to again 10 to the power minus 8 coulomb. So magnitude of Q1 and Q2 are same, that is 10 to the power minus 8. So we'll find E1A, magnitude of E1A equal to, okay, for example, if this x plus x to 2x, so I have written 2 into k into 10 to the power minus 8, this charge 10 to the power minus 8 divided by 0.05 square. If we solve this by putting the formula, 2 into k value 9 into 10 to the power 9 into 10 to the power minus 8 divided by all this mathematically we will solve, we will get 7.2 into 10 to the power 4 Newton per coulomb is the unit for electric field. Now we will find the vector notation, that is this is the only the magnitude. What about the direction? You see here at point A both are towards right, so resultant will also towards right. So EA equal to 7.2 into 10 to the power 4 Newton per coulomb directed towards right. Okay, this is over. Then we will see electric field at point B. At point B, one is towards left and one is towards right. You can see. So at point B, E1B is towards left and E2B is towards right. E1B toward left, E2b toward right. You can see the point B here. At point B, E1b towards left, positive charge, E2b towards right. Okay. Now we'll see the distance. B is at a distance of 0.05 meter from Q1. This is the distance. And B is at a distance of this, that is 0.15 from Q2. So here the distances will change, but the magnitude of the charge, that is Q1 and Q2, it will remain same. So at point B, the resultant field will be subtracted. At point B, one is left, one is right, so it will be subtracted. But at this point, it is subtracted, but we have to know from which field will subtract which field. That means which field is greater and which field is smaller, so that we can subtract the magnitude of smaller field from the magnitude of greater field. So we will first calculate E1b and E2b separately. So E1b will be equal to same formula K Q1 by, here what is the distance, you see already I have told 0.05, and for Q2 it is 0.01. For Q2 it is 0.15 meter. Okay. So you see here E1b equal to K Q1 by this. After solving we will get 3.6 into 10 to the 4 Newton per coulomb. Please do the calculation properly. Okay, I am leaving this for you. So E1b is towards left. E1b, it is towards left, and E2b towards right. E2b, everything will be same except the distance, that is 0.15 square. So if we will solve, we will get 4 into 10 to the power 3 Newton per coulomb, and it is towards right. Okay. Next we'll see which one is bigger, which one is smaller. This is a simple maths. So left side what we are having, left side 3.6 into 10 to the power 4, right side 4 into 10 to the power 3, which is bigger. Make the exponents common. So 3.6 into 10 to the power 4 can be written as 36 into 10 to the power 3. Okay, which is obviously greater than 36 into 10 to the power 3 is obviously greater than 4 into 10 to the power 3. So left side we have strong field, right side we have weak field. From where to where we will subtract? We will subtract this from this. So E2b, okay, will be equal to left side 3.6 into 10 to the power 4 minus right side 4 into 10 to the power 3. So you subtract, how much you will get? You will get 3.2 into 10 to the power 4 Newton per coulomb. What will be the direction? Left side we have strong field. See 36 into 10 to the power 3, right side we have less strong field. So it will be, direction will be towards left. Third point is point C. Point C, you see angle is 120 degree. One vector, second vector, this is the resultant. So first vector square plus second vector square plus 2 into first vector into second vector, cos of angle between these two vectors and square root of it. Okay. So already we have solved this type of problem. So EC will be equal to square root of this quantity I have already written, and cos of 120 is minus half. And what is the direction? The direction is towards right. Okay. So you find E1c and E2c. E1c and E2c, they will be also same in magnitude, because charge, magnitude of charge Q1 and Q2 is same, distance also same, 0.01, sorry 0.1, and here also 0.1 meter. So magnitude of both the charges are same. That is, we will find 9 into 10 to the power 9 into 10 to the power minus 8. Now it is the distance here, 0.01 square. So we got, after solving we got 9 into 10 to the power 3. What is 9 into 10 to the power 3? It is the magnitude of this charge, magnitude of this charge. Till now I have not found the resultant. Resultant is square root of, this is first field, this square plus 2 into this into minus half. Okay, after solving what we are getting, we will get 9 into 10 to the power 3 Newton per coulomb towards right, towards right. Students, see, this problem I have solved explicitly by taking each and every point very detailed. Okay, in the exam you need not to write so many things. You skip some steps in between and you write your answer. This is for explanation part only. Thank you.